Hey guys, this is Mr. H. I wanted to do one more video. And this video I think is more important than the one that I did before. And the primary reason is I want to show you how, when you're trying to do inverse functions, how to check your work to kind of make sure it's correct. And that's, for me, that's something that's very important. I see a lot of students who do questions. They think they've done things properly, algebraically, everything is correct, but they miss it. They make careless mistakes, or they just make some errors, and they wind up getting problems wrong. So I always like to show my students how to check whatever they're doing. So what I wanted to do is I wanted to show you, when you're doing inverse functions, how do you check to make sure that the inverse functions are actually, in fact, inverses? And we're going to use a graphing calculator. So what I'm going to do is I'm going to start by showing you how to come up with the inverse, and then I'm going to show you how to check it. Okay, and I'm going to go a little quickly through the inverse part, because that's not, I've already got a couple of videos out there that if you need to refer to, you can go and look at those. All right, so what we have here, this is a level 2 from Delta Math. Let me write the problem down real quick. We got f of x is equal to the third root of x minus 6 divided by 4. And they want us to come up with the inverse. So let me bring up Delta Math. All right, so the very first thing I'm going to do is I'm going to use PEMDAS. And first thing is I'm subtracting 6. That's the first thing I'm doing. And then I'm taking the third root. And then the last thing that I'm doing is dividing by 4. That's what PEMDAS is telling us. Okay, so once I know that, I'm going to do the inverses. The inverse of dividing by 4 is multiplying by 4. The inverse of taking the cube root is raising it to the third power. And the inverse of subtracting 6 obviously is adding 6. We're going to do this one first, we're going to do this one second, and we're going to do this third, and that should give us our inverse. So let's go through it. So the very first thing that I do is multiply by 4. Next thing I'm going to do is raise that to the third power. So those two things, and then I'm just going to add 6. So that's my inverse. Now, what I want, well, actually, this would be my inverse notation, right? But now what I want to do, excuse me, is I want to check this to make sure that these are, in fact, inverses. So what I'm going to do is I'm going to use my graphing calculator. So let me get this set up. So the very first thing I'm going to do is I am going to enter the original. So the original is the cube root of x minus 6. So in order to do that, I'm going to use this. That's going to be 3. Inside is going to be x minus 6. Oops, I should have divided first. And then I'm going to divide, control divide. Yep, good. And then I'm going to put 4 on the bottom. All right, so that's the function. And that's what it looks like. Let me see here. I'm going to do menu 45, go back to the original. All right, so that's what the function looks like. Now, I'm going to try to find the inverse. So I'm going to type in my inverse. We said it was parentheses 4x raised to the third power. And then we're going to add 6. And then we press enter. All right, now I'm going to zoom out a little bit so you can see it. You can kind of see that they're inverses, but here's the real check. And this is what I really wanted to show you. If you actually take the inverses, so I'm going to, oops. So what I'm going to do is I'm going to take the original one, the original function, which was in f of 1, and then I'm going to take the inverse function, which was in f of 2, and I'm going to store that as, or put that inside as the input. Now, if you take the inverse function and you store it into the original function, if they actually are inverses, you should get the function y equals x, because that indicates that they're actually inverses. So when I press enter, you can see that I do get the line y equals x. So what I've just shown by using the inverse as the input into the original function is that they are in fact inverses. So I know that that inverse that I came up with is actually the correct answer. So what I'm doing is going to be 4x third plus 6, so it would be this one. We've already checked it, so we know that this is right, and it tells us that it's right. Now I'm going to do one that's a little bit more difficult, so I'm going to go to level 4. Let's see what we got here. So what I'm going to do now is let me clear this off my iPad. And then I'm going to write the new function f of x equals, it's the fourth root of 7 to the x power plus 9 divided by 9. Excuse me. All right, so now I need to find the inverse, and then more importantly, I need to check it to make sure it's right. So using PEMDAS, first thing, I'm going to, I see that x is being raised is the exponent for the exponential function with the base of 7. So I'm saying that's the first thing that I'm doing. The next thing that I'm doing is I'm taking the fourth root. So I am taking the fourth root. Let me do that better. And then the third thing that I'm doing is I'm adding 9 right here. And then the last thing that I'm doing is dividing by 9. Now, the reason that I'm going in that order is this stuff on top is basically all inside of parentheses. So I'm starting with the exponential, and then I go to the fourth root, and then I go to the sum, and then I go to the division, the ratio. Now, once I've got the operations using PEMDAS, I'm just going to take the inverses. So the inverse of dividing by 9 is multiplying by 9. The inverse of adding 9 is subtracting 9. The inverse of taking the fourth root is raising it to the fourth power. And the inverse of having something with a base of 7 is using the logarithm with a base of 7. Right? So that's what I'm going to do. I'm going to do this first, going to do this second, this third, this fourth. So I always know that no matter what I do when I get done, I should have x on one side and y by itself. So now I'm just going to do the steps that this is telling me. So I'm going to multiply by 9. I've done that. And then I'm going to subtract 9 from that product. Done that. And then I'm going to raise that difference to the fourth power. And then I'm going to take the log of that difference, or log of that raised to the fourth power. And the base is going to be 7. Now, so that is the inverse function. Log 7, 9x minus 9 raised to the fourth power. So let's go and check it. So we're going to use the calculator again. Let's get rid of this stuff. It's going to be menu 14. Menu 14. And then the first function is the original function, which is control divide. It's the ratio. I'm going to take the fourth root. So here's what I need. I'm going to take the fourth root of 9 to the x power, or 7 to the x power, 7 to the x power. And then in the denominator, I forgot this part up here. In the numerator, we still have plus 9. And then in the denominator, we are going to have 9. All right, so that's the original function. That's what it looks like. It's definitely exponential. So now I want to do the other one, the inverse function. So I press tab and I'm going to enter this one. So I'm starting out with the log with a base of 7. And then inside, I am taking the log. So I'm going to put inside here, just to make sure this is clean, I'm going to do 9x minus 9. And then I'm going to raise that to the fourth power. And that's what I'm taking the log of. So I press enter, and wow, that looks weird. But I think this piece over here basically would be cut off. And I think the reason that it's kind of going back over here is because we're taking the fourth power. But anyway, now this doesn't look like it's quite the inverse, but here's the test. I'm just going to go tab, I'm going to go the original function, and then as the input to the original function, I'm going to take the inverse that I've created, and then I'm going to graph it. Now, this part right here, it should go all the way here. So something is a little off. But this part right here actually is part of the function y equals x. Something is off a little bit. I'm trying to double check what I got here. Something is definitely off a little bit. So let me see here. I think this still works though. So if I go here, what's my answer? Log 7, 9. It's this one right here, the one at the bottom. So this is what I came up with. This is what I think is the answer. Let me submit it. And it tells me that that's right. Now the graph looked a little weird. I think what you would have to do is you'd have to restrict the domain of the inverse function in order to make that work. And of course, I didn't do that. But I'm going to do one more just to make sure that what we're doing is pretty clear. All right, so I'm going to get a new problem here. And let's see what we got. We got the function is equal to e, and it's the fifth root of x plus 9 is the exponent. Okay, so let me bring up my iPad and let's go through it. All right, so I'm going to make a little change here so that you can see that basically all of this stuff is raised to the, it's the exponent for the base e. All right, so if I'm doing PEMDAS, the very first thing that I'm doing is this fifth root. So I'm taking the fifth root of x. I'm doing that first. The second thing that I'm doing is I'm adding 9 to that fifth root. And then the last thing that I'm doing is I'm raising it to the base e. Okay, so that's an exponential. Now that I've done PEMDAS on there, I'm going to do the inverses. So the inverse of raising something to the base e is to take the natural log of that something. The next thing I'm going to do, inverse, is subtract 9. And then the final thing that I'm doing is I'm taking the fifth root. So the inverse is raising it to the fifth power. Now I'm going to do the natural log first. I'm going to subtract 9 second, and then I'm going to take the fifth, raise it to the fifth power third. So here is my original. And so here's what I'm going to do. I'm going to take the natural log. I don't like that. The natural log of x. Okay. And then I'm going to subtract 9. And then this whole thing, that whole difference, I'm going to raise to the fifth power. That's the inverse. Now we're going to check it. So we're going to grab the calculator. I'm going to get rid of this. It's going to be menu 14, delete it. And then what I'm going to do is I'm going to enter the original. The original is E. We're going to do tab. We're going to do tab, and it's going to be E. And the exponential part is going to be the fifth root. Now, these look a lot scarier than they actually are. And then oops, that's not supposed to be a Q, that's supposed to be an X. So this is supposed to be an X. And then we get, we're still as the exponent, and then we're going to put +9. And then we press enter. I don't see that exponential function. Let me go back and make sure that everything looks good. It does. So now what I'm going to do is I'm just going to zoom out a little bit. So I'm going to menu 44, and then here's the center, here's the center, here's the center, here's the center. So there it is. Wow, it's way up there. All right, so now I found the function, the original function. So now what I'm going to do is I'm going to enter the inverse. And the inverse was parentheses, the natural log of x. So natural log of x, and then -9. And then we're going to raise that whole thing to the 5th power. All right. And then we press enter. And now, just on the surface, you can see that these two definitely look like inverses. But to check it, all we're going to do is we're going to do tab again, and we're going to take the original function, and we are going to put as an input the inverse function. And if they are inverses, we should see the vertical line, or we should see the y equals x line. Now, it doesn't go down here, and that's probably because the domains have to be restricted in order to make this work. But this part is definitely, you can see this is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 going up. So this is definitely the y equals x line here. So this right here is telling me that these two functions are indeed inverses of each other. We just checked it. We just kind of proved it. So now if I go over here, what am I looking for? The natural log raised to the 5th power. The natural log of x -9 raised to the 5th power, which would be this one. And we just checked it. So unless I keyed something in wrong, that's the answer. So that's how you can check whatever you're doing. Let me go back over and see if I can make this. Like if I go into one of these functions, let's say I make this, delete this and make it a 4. Oops, that's not what I wanted to do. Actually, that's fine. Now see, now the function that the inverse of what we had, you can see that it's not a straight line. This is no longer a straight line. So these two graphs are not functions of each other. And of course they're not, because I changed them up. So, but if they're not functions of each other, you're going to get something that's not, it's not y equals x. And if it's not y equals x, then that means those two functions are inverses. I hope that's clear. I hope you guys see that. Now, I'm using a TI-NSPIRE. You can use a TI-84. You can do the same thing with that. You can use pretty much any graphing calculator I think should work. I'm more comfortable with the TI-84 and the TI-NSPIRE, but that's how you can check when you've done your algebra if the function, the inverse that you found, is actually the inverse of the function. If it doesn't create the straight line y equals x, then you've made a mistake someplace. I hope that's clear. I'm going to stop this recording and let me know what you think.